Hey, new handle. This is strict pronation handle. Alright, so first about the question of what is it. We have this kind of section here to the sides where the weights go. And there is two things about this structure. That the purpose of this is that adding weights will keep the center of mass on the same spot always. Here, the center of mass needs to stay on the same spot, so that if you add weights, the addition isn't changing the lever, because if you change weights, you do not want to be changing two variables, because then the resistance is hard to calculate. You always want to be changing only one variable, in this case the weight, and not the lever. So you want the center of mass to stay on the same spot, and hence the weights go to the sides and not to the front, because if it would go this direction, then you put more plates, the weights that you add to it are further away than the weights which were previously there. So the lever from these additional weights will be higher, bigger and bigger and bigger, meaning that they create a bigger momentum here than the first weights. And hence and that's why the bar where you put the weights goes to the sides, so that the lever does not change. The weights are always the same distance from your hand if you put them here, like so. Now the weights are both same distance from your hand. And if you put additional weights here, they're always the same distance away. Alright? So regarding this thing, that you have to keep the center of the weight here, when you add weights, you need to add them symmetrically, so that here is the same amount than here, and the lever also is the same, if you don't put them all the way to the board. Alright? So adding symmetrically weights, and also that the weights goes to the side, make it possible that the center of mass stays on the same spot on the handle. And hence there is no addition changing of the lever with changing of the weights. Alright? So that's the first thing about the structure of this handle. Second thing about the structure of this handle is that there are screws here. And they are there so that you can always take your grip from the exact same spot. These screws are now 2 centimeters apart from each other, which is pretty ideal for my fingers. If you have bigger fingers, you might want to space them like 2.5 centimeters, or if you have really small fingers, maybe 1 centimeter or something. But to me, it works that they are 2 centimeters apart. And I have written there the scales so that it reads how many centimeters there is between them. It's easy to know. Now you are not cheating yourself by every time moving it. And you can always get the same position. And if you do the other arm, the screws are on both sides. Alright? So here is the screws. the third thing about the structural, which if you want to make this, you need to be mindful of, is that there is a scale here. And what is important about this scale, that if you make this, you have to have two sections of same length. Example, this section here to here is 10 centimeters. From the middle of this rod, where the center of mass is, from middle of this spot to there is 10 centimeters. And here to here is another 10 centimeters. So here to here is 20 centimeters. Here to here is 10 centimeters. So you have two sections of 10 centimeters here. Why this is important is because you will be using only this part of the handle. Like here, go here, 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 and here. Because if you watched my video about the wooden handle 2.0, in that I explained this principle principle of adding weights to the handle, so that you can keep a track on what kind of torque it creates. So let's go over that quick here. So that if you start now, let's think about you have 1 kilogram of weight here, and you are doing this from this spot of 10 centimeters. So the torque this is creating, you can now think about it in kilogram centimeters. That is now our imaginary unit of torque. So it's now in this position, the torque would be 1 kilogram times 10 centimeters. It would be 10 kilogram centimeters, the torque. All right. Now that you move, you progress and you get stronger. You go all the way here. Okay, now you have doubled the lever because you had doubled the momentum because you had doubled the lever without changing the weight. You still have the 1 kilogram of weight, but since you now had 20 centimeters of lever, now the torque which this creates is 20 kilogram centimeters, because 1 kilogram times 20 centimeters is 20 kilogram centimeters. All right, now you cannot go any more further, so you would need to add weights. But what kind of weights should you add so that you could keep using this same handle? All right. So how you solve this with this kind of setup is that you just double the weight here and half the lever. All right. Now that you are in here and you have 1 kilogram weight, what you do now to keep the same but go back to here is you double this weight here. Now it's 2 kilograms. And you halve the lever. Now you're back to 10 centimeters. But now here we had the lever from 1 kilograms and 20 centimeters. The lever was 20 kilogram centimeters. Now that we go here and double the weight, we had 2 kilos times 10 centimeters. It's also 20 kilogram centimeters. So you have now the same lever, the same momentum here with 2 kilos, then you had here with 1 kilo. All right. And how I have intended this to be used is that you start with 2.5 kilos, like so. These are 1.25 kilos. You start from 2.5 kilos and you start from here. You progress all the way through. Then you here with 20 centimeters lever and 2.5 kilos, you are having, 25 kilogram centimeters. No, 50 kilogram centimeters. Yes, you have 50 kilogram centimeters momentum from this position. All right, if you wanna keep you 50 kilogram centimeters while you keep progressing, because you cannot make it longer since you are running out of the scale here, you double this weight so that you either put 5 kilogram plates here on both sides so that you have, I mean, you put 2.5 kilogram plates on both sides, so you have together 5 kilos when you previously now have 2.5 kilos. Oh, you just add one more plates on here. Like so. And then you go back here on the halfway mark. Remember that this is halfway mark between this point and this point. So now you have also here with there being 2.5 kilos, and you have the 20 centimeters lever. It was the 50 kilogram centimeters of torque momentum. And now that you double that and put here 5 kilograms, and you go back here, you have the same lever, because 5 times 10 is also 50 kilogram centimeters of torque. And now you can progress again through all of these. Then you here, and then what you do is just put there again, double this weight and half the lever. So it keeps your ratios the same. And that's how this is intended to be used. And that's why it's important that you have here the it's important, that's why it's important that you have two sections of same length, because you will be using this section here only. Here you don't even need the markings here, because you go from here to the halfway mark, and then you double the weight, and then you just climb back here, go back here and double the weight, and you can use this forever. All right, so that's also important, these two sections, because of this it's easy to then calculate what you are doing with it, where you are going, and if you run out of the room, how do you progress from this point? You progress it by doubling the weight and halving the lever, and then you are back here again and you can progress again. All right? Then there is why is this a board? Why am I grabbing a board? Why isn't this circular, this shape where I'm grabbing it? Well, in I think that it's better to have this as a board, because the way you will grab this, you are not grabbing this like this. You need to grab it like this. Because, well, if you experiment with it yourself, you will find out why. But like in this position, when you have the handle in this position, you see that it's pointing upwards. It's not totally perpendicular to the wrist. And wrist is the one which is rotating. So you see that it's not like this. You would like to have it like this, so that you have 90 degrees here. That's the ideal position. And you will feel it when you train with it, that here it feels the best. Because here it feels like it wants to do also this. Because that's what it kind of wants to do, since it's like the leaning here. and not directly like this. So because you want to grab it like this, that's why you want it to be a board. Because this board is easier to grab with only the fingertips. Like so. If you grab it like here. Alright, so that was all the structural points regarding this handle. Alright then, why do you need this? And like I said in the beginning, this is a strict handle, strict pronation handle. And the strictness is, in my opinion, very nice to have. And the previous handles did not have it. Because it was up to you to have so great body control that you do it strict. But even then, there is minute things like you moving your elbow a bit. If you lift something with the pronator and you lift your elbow a bit, you see that the angle is changing. You're helping the pronator to do the repetition. Like example, think about I'm trying to do this now. And now I'm helping it with the elbow. You see, I did not do it with the pronator because I got this here free from the elbow and then I just returned the elbow back and kept this angle. So I'm not really doing it with the pronator dynamically. And hence even minute things like this, you can like steer it by doing it little by little like this. And even though you would not think you are doing it, the body is very smart. Your body is very smart in cheating. So you will subconsciously do it. Because your body kind of subconsciously knows how to cheat. You know? Like even if you do bench press and your butt comes after bench, you did not like make that decision, hey, I will now raise my butt so that I am stronger since I can use my lower chest. Your body knows it. Your body knows that here I'm strong. And then it's just subconsciously you just do it. And same thing here. If you don't have anything to, like you can think that you keep your elbow stuck on your side, but even then you can lean. And leaning achieve the same cheating by you leaning. Because what you are attempting to do with the cheating is change this humerus bone, this bone here. You try to change this angle. With raising the elbow, it's obvious that you are trying to change the angle of this bone and hence help cheat the pronator muscle. But if you are also leaning, even though you keep your elbow on your side, if you just lean, you are doing the same thing. Now, if you start from this position and you lean, you see that I got it free now. I got this 30 degrees of turn from this to this free because I did not even engage my pronator. And still I lifted something in this movement. Like starting from here and going here. You see? I'm already halfway done the exercise. And now I can just do the rest. I got the start free. And if I do just here and then return and come again, I did free the two portions, or only what I did. I statically hold this position when I came back, and then just did it again. All this is good in arm wrestling competition, because there you want to cheat because you want to be strong. And obviously you can lift more if you cheat, but it's not always good to cheat when you are training. In competition, good to cheat, but in training, not so much. Alright, so that's that. And the second thing of why you would like to have this is because in the non-strict movements, progress is kind of hard to quantify, because if you leaned and then you don't lean and then you lean even more, like the question is not ever answered that was your progress, that if you get today 2 repetitions more than last time, was it because you cheated more or because you got stronger? Like, you cannot really know that if you are not like videotaping yourself doing the movement or have a partner or somebody watch you do it, because really hard to see these minute cheating movements what you are doing. So that's why you would also want to have a strict movement, because the only variable is did you get stronger, because the strictness of the movement forces you to always do it the same way. All right. The third thing why would you want to have a strict movement is because strict movements are less prone to injury and cause less inflammation. Like, you can think about if you just do this movement like this every time, cheating it as much as you can. What is then bearing the weight? It's your joint. The joint, the structural strength of the joint is giving you the initial momentum, which then makes it easy for the muscle to finish the movement. So you are using the structural strength of the joint to help the muscle. It's kind of good if you would like to condition the joint occasionally. And even then you would like to do that conditioning control and not some freak movements where you just try your hardest. You might want to have some kind of measurable amount, and if any pain happens, you stop. But with this, inflammation and pain is very easy to develop, since you are like hitting the joint, the hyperextended position pretty much in this movement, which is where you would not want to place lots of like stress, because you are there, the joint is the most prone to injury, because from the hyperextended points, further rotation from the hyperextended point will lead to injury, because the joint just cannot extend even more. In this case, extend means rotate. Something ligaments will tear here if you just bang here and trust on the structure integrity of your joint. So that's why also you would like to have a strict movement, so you eliminate this kind of using the structure integrity of the hyperextended position to get the strength to initiate the movement. And then the last thing about why you would want to have this is, even though you might have issues if you normal pronator movements, which you do like this with the belt and stuff, or other handles, if you have some kind of pain here, strict movements might still be alright. You still might be totally fine doing these, because the pain might be caused by you doing the little hitching at the beginning on the hyperextended position, because it will further stretch those ligaments, which in your case, if you have pain, are already damaged somewhat due to the pain. So if you now just continue banging the movement with the cheating form, or this, like even this belt thing, like I might get the belt. Even these belt exercises for pronator are not strict, and you are still using momentum on them. And because you doing them like this, you start from this position and you start pulling. And then you usually do the pronation here. Like what you are doing when you start the movement by pulling, you are developing momentum, like you are already putting the weight to move, which then make it easier for your pronator to do the pronation since the weights are already moving. But what you are using, but when you have the wrist on this position when you start moving the weights, you are using this hyperextended position as a lock, so that you are pulling against it to cause the weights to rise, and then you do the pronator movement. So even in this belt exercise, it's not strict, because you are still using like this pulling motion. The pulling motion achieves somewhat the same as with these movements, this kind of thing achieves. Obviously you can do this totally strict if you just do it like this and not have their momentum like pulling it fast. But it still, it's hard to quantify how much you cheated and everything. So even still, I would not call the belt exercises strict in that regard. And hence, even if you would have pain on the belt and pain in some other, this might still feel good, because you are not doing any type of momentum on this. This is totally strict. Alright then, how do you use this? Alright, I put here a video which shows me using it, but basically what you want to be mindful of is that you take the grip so that it's 90 degrees to this bone, not like this. You don't grab it like you would grab a normal handle, because if you do so, the handle is not 90 degrees to the wrist, and it will feel weird doing it strict. Alright? So you grab it like so, like you pretty much have your thumb, the side of the thumb here on this edge here, and then fingers like this, and you have little gap here, like so. You have it like so, like so. So it pretty much rests on this, Not here, but here. All right. First, you grab it like this. From the point that first you of course put the weights here. Let's say I want to start with the 2.5 kilos. And now you put them symmetrically there. Alright, then you take your spot and you grip it the right way, which is like this. Meaning that in the pinky finger is all the way touching the handle from the side. But here, the thumb is touching the side and not this finger. This finger is not touching on here the handle. Here is space. Here is space. But the thumb is touching it, like so. Because now it's 90 degrees to the wrist when you are in the position doing it. And then you keep your elbow somewhat 90 degrees and you put your hand on the side of whatever where you're doing it. If you do it on the chair, then on the side of a chair, and like that, it's like here the video is spinning here, so let's just comment on the video. Like there in the video, like when I'm doing it, you can see that this part of my hand never rises from the chair or whatever you are doing it. This light will not shine through your arm and the chair. Your hand stays on the chair. You do not rise it up, because if you rise it up, you will change this movement so that you are now no longer doing the movement perpendicular to the gravity, which makes it then obviously easier. Like example, because the cheating what happens from you rising your hand up basically tries to do this. Okay, think about now doing the movement like this. Is there pronation activation? No, because the gravity is in doing this, but this. So when you are raising your hand off the bench, you are basically trying to take the pressure off the pronator, because now this, it's more of this down pressure, which is now holding partially the weight. It's the same thing as with the bicep. If you have biceps doing this, it's totally 90 degrees to the gravity. If you have it here, it's only 45 degrees to the gravity. The lever is shorter. And now it's 90 degrees, like it's totally, say, to have no pressure coming to the bicep, since it goes straight to the bone and to the table. So there is no, and that's what you are trying to, that is the principle by which you are trying to also cheat if you raise your arm doing this. Because then also you are changing, because now it's 90 degrees to the pronator, which is the harder position. Now it's no longer pronation, because gravity doesn't try to do this, but this. You are now contributing the force to the other muscles than the pronator, which will aid pronator. Because now this movement also is now holding the weight. And more you raise it, now there is no pronation, it's just this movement which is doing the holding. So that's why you have to keep to do this trick, you have to keep the hand touching the table. Or whatever, the chair, or whatever you are doing it against. What 3 points need to be touching the same surface? The wrist, the elbow, and the shoulder. That way it's also always on the same position. All right. Okay, so how do you then make this if you want to make this? Like, what I did is I used this kind of circular hole making saw, whatever this is. Circular hole making sawing drill bit, whatever. To make this hole, which fits this. And this is just a piece of a broomstick, by the way. And how I made these sections here so wide, I used this wide blade on this angle grinder. Like, this is made for grinding metal, but it gets the job done pretty easily on this. So that you can use that. So that's how you make this. With that you make this, put it on place, and then you measure the, obviously you can then screw this on place by putting it through here, but I didn't because I demonstrated. Now I need to remove it still. So, but then you put the screws here. First you measure the distance from the center of this. You measure the distance from the center of this rod to whatever distance you want to make it. If you want make it so that your lever is the same as mine, then you take 10 centimeters and then another 10 centimeters. And then you section the latter part of the 10 centimeters, the other 10 centimeters. From here to here, you do not measure, you do not make markings. From here to here, you make markings as you see fit. Maybe you wanna do the 2.5 centimeters and not 2 centimeters alike. I did. Then you just would mark them like here 2.5, 2.5, and 2.5, and then you would have 4 sections, I guess, or 5, since you have this section here too. Anyhow, now I made them between 2 sections, so I have 1, 2, 3, 4, 5, 6 sections, which I can progress. All right. So that's that. How you make this, and then if you don't have screws which do not perfectly fit this, meaning that they stick out, like mine did. My screws also stick out. You can just put them here so that they stick out, and then you use this kind of metal file, and you just file the ends of the screws so that you can see that they are no longer issue. They just, you can see them here, but they do not poke out anymore. So that's how you can make this so that the screws do not poke out without you having to worry too much of finding the right side of a right length screws. All right. And then another point on this, that if making this and this hole seems like too much work, you can just make a solution like this, that you just screw here a hole with regular screws, drill bits, or whatever, like these are even hand operating these. So you can just make that and use a bolt like this. But this is, I guess this is, I don't know what millimeter this is, but you just get it so that it's the same as your hole, and these are same and everything is made for with this. And then you can just put this through the hole. Let's think that this would be a smaller one. You put this through the hole and then like so. and you would have this kind of setup. And now, if you just want to use weights with this, you can attach the weights like so. You just make sure that this thing is so big that it doesn't go through the hole in the weight. And then you just do this. And now you have achieved the same as with, obviously this bolt is not ideal for this purpose since it's not threaded all the way. So I cannot tighten it so that this would stick to this wood. But in your case, you would like to buy a bolt where it's threaded all the way, meaning that there is this rotation. You can spin this as far as you can want until it's tight. Like I can't because there is not enough threadage. Anyhow, you could achieve this same with the bolt like this kind of setup. It might be even handier than my solution, because you could have maybe a wing nut, meaning a nut where there is these wings, so it's easier to even put on tight with hands. And also these kind of things are also sold with the wings here. So you could have wings on both ends of the nut. So it's easier to hand using your hand and get it tight. Where this might not be ideal for it. But that's another solution how you could make this mechanism by which you get the weight stick to it. Alright, and that's it. Then you just mark this if you want, or then you just remember what was what. And that's how you make it. Alright, just a board. My wooden piece is, here is 20. It's 17 centimeters, no, it's 37 centimeters. This entire length is 37 centimeters. The width of it is 4.75 centimeters. And the thickness of it is 2.2 centimeters. So there's the dimensions of this. And obviously if you want to make this kind of a setup and not the screws type of a setup, you need to find a broomstick which has the diameter which is a little bit over the dimension of your plates, the hole. Because these are sticking to it with friction. And the edge, this wedge here makes it so that you can squeeze this like so. The putting of weights is easy because these squeeze. Now, and it still creates pressure outside, which makes this stick to it. So, in my case, my broomstick handle is 32 millimeters, and these weights are, the hole in these are 30 millimeters. So there is pretty much 1 or 2 millimeter difference. So that's also why you might want to use this if you have hard time finding a solution like making this happen. Because it requires that you find a broomstick handle which is exactly 2 millimeters or 1 millimeter thicker than this. So it might become hard if you have different sizes of these or do not just find this kind of broomstick. So that's why you might want to go with a bolt setup also. So that's that. So that's how we make it, and that was all. Bye.